Hello mathematicians, welcome to another beautiful edition of Math Made Easy with Victor Inayo from Crunching Mathematics TV. Thank you very much guys for subscribing. I hope you guys are enjoying the lecture so far. And if you are just joining me on this channel, you're just seeing this face, I am your captain in mathematics. I lead the ship to the journey in the journey of mathematics. So if you're just joining me in this channel, why not hit the like and subscribe button and make sure that your notification bell is turned on, so that whenever I drop mathematics content every day, you'll be the first to be notified. So without wasting much time, let's go into the board and let's see what we have today. Okay, yesterday I dropped an assignment for us to take home. Some people made the mistake trying to solve the assignment. We have to simplify 4 raised to power 2 times 4 raised to power 3. This is so easy because now we have a unit as 4 that we know in indices we work with exponentials. So let's look at what we have in the exponentials. We have 2 and 3. So according to the law of indices, this times is going to change to plus. So we now have what? 2 plus what? 3. And that is going to give us 4 raised to power 5. So simple as that. I think that's not so much. And we had another simplification. There are 2 number 2 assignments. The other one is simplify a raised to power 13 divided by a raised to power 11, right? So now we have a whole unit of a here. Now we deal with our exponential again. We have 13 and 11. And now according to the law of indices, divide changes to what? Minus, negative sign. So the exponential we have 13, now give us a 13 minus 11, which will in turn give us a raised to power 13 minus 11 is 2, a raised to power 2. So that is so simple as that. For those that don't understand it very well, that's in making comment. If you still have any question, go ahead and drop it. So without wasting much time, let's move ahead. Like I promised yesterday, I told you that we shall be looking at logarithms today. But I think some people said I need to explain more about indices. We need to go into in-depth of indices. But there's some other parts of indices that we have not covered. So we shall be postponing our lecture about logarithms today. Let's focus on indices. So with that, we have to look at let's look at the product of indices. Products of indices. A product of indices is something like, we have something like we are still looking at product of indices. So now let's look if we have a problem like x to s squared all over 3 cubed all over we have s squared bracket 3 outside. We have 2 exponentials here. We have 2 and we have what? 3. So what do? This simply means x 2 times 3, which will give us what? 2 times 3 will give us 6, which S6, that's just the answer. That's the product of indices we're talking about. Let's look at 2 other examples before we move forward. What about if we have something like y 4 all squared, power of squared. So we have two exponential values here. We have the value of y, we have the value of 4, and we have the value of 2. So this in turn means y 4 times y 4. We have the whole y here. We have 4 times will now change to plus 4 plus 4, which will now give us what? Y 8. So simple. Is that not simple enough? If you have any problem with that, let me know. I think that's simple enough. Because when dealing with indices, you are dealing with the exponents, exponential values, not the main value. So we'll take one more example here. Let's see what happens. Now if we have a value like, we have z cubed all raised to power 5. What this is, we can just solve this by saying 3 times 5, 15. Z 15, but no, we won't do it that way. What we have to do, let's work it, let's follow the process. This one means z into 5, z3 into 5, z cubed times z cubed times z cubed times z cubed times z cubed. Are we up to 5? 1, 2, 3, 4, 5. Now we'll take a whole value of z because that is the main value. Then we know we are dealing with exponential, and the value here is times changes to what? Plus when it comes to indices. Are you getting me? So 3 plus 3 plus 3 plus 3 plus 3. That's what? 3 plus 3 plus 3 plus 3 plus 3. We have 5 values here. So 3 plus 3 gives us 6. 6 plus 3, 9, 9 plus 3, 12, 12 plus 3, 15. So if you look at this, we have 3 times 5, 15. So that be the same answer. So now we have z 15 here. So it's very simple as that. Do not allow anything to distract you. Math is so simple as that. You don't have to worry about anything here. So now let's move forward. We have now if we have something like x cubed, x squared cubed. What this simply implies is that s squared times s squared times x squared, right? Now we have the value of x here. So we have the exponent to be 2, but they are going to, this times is going to change to plus. So we have 2 plus 2 plus 2, which equals to, this now gives us x6. 2 times 2, 4 times 2 plus 2, 4, 2 plus 4 plus 2, 6, gives us x6. And if we have to do it this way, in simple way, we can just say 2 times 3, 6, x6 will give us the same answer. But I just needed us to go through the normal process. What about if we have something like a y4 all squared? y4 all squared. We can simply say 4 times 2 equals to y8. But because I want us to follow the process, so we're going to solve it. We have what? y4 times y4, because it's squared, it's only 2. y4 times y4. So we bring the single value of y. 4 plus 4. That will give us y8. You can see everything is falling in place the way it's supposed to be. Now we'll take the last example before we take a fractional indices. Let's look at our z3, 5 as exponents. We have 2 values. Now let's take our last example where we have z3 3 bracket 5. We have two exponential value here, 3 and 5. So this simply means Z3 into 5 places. It means Z3 times Z3 times Z3 times Z3 times Z3. So what we have here, we have a single value of Z now, because we are dealing with the exponential of values. And the time changes to plus. We have 3 plus 3 plus 3 plus 3 plus 3, which will give us Z15. Alright? And if we times this, 3 times 5 is equal to 15, it will give us the same value. So in general, x, a, b is the same thing as what? X times a times x times b, which will give us what? X, a plus b. That is what it means in general. So that will be all for that. So with that, we'll now be looking at fractional indices, where we'll end. So this is our last topic for today. So you are finding value in this math so far, why not smash the like and subscribe button, and make sure you turn on your notification bell. Thank you very much. So we'll now look at fractional indices. We all know that root x is a short form of square root of x. Root x is a short form for square root of x. So if we have a problem like this, simplify root x. So what do? Now let root x represent p. Let root x be xp. Let's root x equal to what? Xp. So anywhere you see the value of root x, you take it at what? Xp. So if you have a problem like s squared p, what do? If we have a problem like how s squared p. So this one simply means root x times root x p equal to what? X. Because we say let's xp is equal to root x, right?